Good afternoon, everyone. Thank you for joining us. We'll just take a few moments for folks to log on and join the Zoom. There's quite a few people in the waiting room, so thanks so much for taking your time this afternoon to hear from our Scientific and Technical Subcommittee. All right, we're going to go ahead and get started. So I will kick things off. My name is Molly Siegel. I am the Climate Council Coordinator here at the Governor's Office of Policy Innovation in the Future. And I'm excited to welcome you to the third webinar in our climate science webinar series, hearing from the scientific and technical experts here at the Maine Climate Council. You can see up on the slide here, we have a couple of upcoming webinars, different topic areas that are coming up within the next couple of weeks. So on Tuesday, June 11th, we have a webinar to brief the Maine Climate Council and the public about Maine DEP's new greenhouse gas emissions inventory. That's on June 11th. And then another webinar for folks who are interested in learning more about Maine's Social Vulnerability Index, a very relevant topic, especially for those of you interested in sea level rise and marine systems. So that's coming up on June 14th. You can find the registration links to both of these upcoming webinars on our meeting calendar webpage. That link is here in the slide, and Abigail will drop the link in the chat so that you can go to our calendar webpage and see some upcoming webinars. So with that, I'm going to drop my screen and just share a couple of highlights about how this webinar is going to go today. We'll have some presentations from our scientific experts, and then we'll have a question and answer session where we'll be fielding your questions to the members of the Scientific and Technical Subcommittee. Please use the Q&A box to ask your questions. You should find that at the bottom of your screen. It says Q&A with a little question mark, and that's where we'll be looking to grab your questions. So if you could please use the Q&A box and not the chat, that would be very helpful, because that's where we'll be sifting through all the great questions that come in and fielding them to our experts. We will send the recording of this webinar and the slides out after the presentation, and they will also be posted on that same calendar webpage that Abigail shared. So that should be up within a week or so. If you want to come back and see more or revisit one of the topics that you see today, they will be posted and you can share with folks who weren't able to make it. So I'm going to turn this over to Steve Dickson, one of our co-chairs of the Scientific and Technical Subcommittee, and he will kick off the presentations for you. Over to you, Steve.
Thanks, Molly. I'm going to share my screen here, and we'll get started. Is that working, Molly?
That looks good.
Okay. One more second here to my page. There we go. Well, welcome everyone, and thank you for attending today or for viewing or reviewing this recording in the future. I am Steve Dickson, the state geologist and director of the Maine Geological Survey and a co-chair of the STS. My co-chairs are Dr. Susie Arnold from the Island Institute and Dr. Ivan Fernandez from the University of Maine School of Forest Resources and Climate Change Institute. 5 years ago this month, Governor Janet Mills signed into law an act to promote clean energy jobs and to establish the Maine Climate Council. The law established ambitious goals for greenhouse gas reductions and cost-effective adaptation and resilience in Maine. And it charged the newly created 39-member Maine Climate Council with developing an integrated Maine Climate Action Plan by December 1st of 2020. The law also established the STS to support the work of the council and the working groups. By my count, there are 46 STS members, and an additional 14 or more scientists contributed to the current study that we'll be releasing soon. Alongside the STS is the Equity Subcommittee, and it has worked with all aspects of the council's membership and helped guide the processes this time around. The law also established 6 working groups with various areas of focus that included transportation, buildings, infrastructure and housing, energy, community resilience, public health and emergency management, coastal and marine ecosystems, and natural and working lands, all within the framework of equity and economic development. Since the fall, the STS has advised and been part of a resource for the working groups and also provided an update to the council. The STS was established to identify, monitor, and study and report out the relevant data related to climate change in the state and its effects on the state's climate, species, marine and coastal systems, and natural landscapes, and also on the oceans and other bodies of water. The STS is committed to supporting the work of the Maine Climate Council with the best available science to inform decision-making. In 2020, the STS released its initial comprehensive 370-page report, the Scientific Assessment of Climate Change in Maine. And this is still a great resource still to this date. The following year, the STS released the short report, Maine Climate Science Update 2021, a mere 20 pages. Our 2024 report is about 265 pages and will serve as a reference to the Maine Climate Council, work groups, and really everyone in Maine recovering from storms or planning for the future. The first presentation today will be about sea level rise and storm surge, and it's brought to you by Peter Slovinsky. You'll hear that the rate of sea level rise is increasing. It's no longer an inch per decade, it's more. The tides now are about 7 to 8 inches above what they were when my grandfather was a kid playing on the shores of Jonesport. Future generations will be dealing with a few more feet, not inches. In 2023, the sea level was particularly high, up 2 to 3 inches over what it was in 2022, just a year before. Higher tides mean that waves and flooding from storms can reach higher and farther inland. This report has detailed projections that can be used for planning for the decades to come. In the second presentation, Nichole Price will cover marine topics. And we know that the atmospheric circulation pattern, like the jet stream, affects storm tracks across New England. Similarly, shifting ocean circulation affects water temperatures, nutrients, and the food web, even in the Gulf of Maine. Marine heat waves have been a new thing since about 2010. Atmospheric carbon dioxide makes its way into the ocean, into the seawater, and makes it more acidic, with consequences there for marine life. This report helps us look to the future and find paths forward that are grounded in science with a sense of purpose and hope. With that, I'll turn it over to Pete Slovinsky, and then we'll pass it over to Nichole. Thank you.
Thank you, Steve. Hi, everyone. I'm going to share my screen here. Hopefully everyone can see the presentation that I'm going to be sharing. Thumbs up. Okay.
Looks good.
Welcome. I'm Peter Slovinsky, a marine geologist at the Maine Geological Survey, and I'm presenting some highlights from our sea level rise and storm surge section of the STS report on behalf of my co-authors, Hannah Baranis from the Gulf of Maine Research Institute and Nick Whiteman from the Maine Geological Survey. One of our findings from the current report that basically reflects the 2020 report was that our long-term or century scale changes in sea level that we've been observing along the Maine coast have been matching global changes. And that's been at a rate of about 0.8 inches per decade, roughly about 1.9 millimeters per year. And I'm using data here from the Portland tide gauge, which is the longest serving tide gauge in Maine, which started collecting data in 1912. However, since 2020, the rate of sea level rise has actually increased by about 2.5 times that long-term rate. So now we're seeing about 2 inches of sea level change per decade. And one thing I'd like to point out to you is the last 2 dots on this graph are basically the mean sea level for 2023, this dot here, which eclipsed our highest sea level, which used to be in 2010. And now 2024, so far through the month of April, is eclipsing even 2023. At the same time, our tide gauges, our long-serving tide gauges along the Maine coastline at Portland, Bar Harbor, and Eastport have been setting records in 2023 for mean sea levels. So this graph, this chart is basically showing you where the months of the year from 2023 rank as it relates to all of the monthly mean sea levels recorded since 1912 in Portland, 1947 in Bar Harbor, and 1929 in Eastport. And if you're seeing a red box, that means it set a new record for that month. If you're seeing a yellow box, that means it was in the top 3 for that month, going back to each of those start dates. So from June to November, we pretty much set records for every single month in 2023. And that trend has continued in 2024. Again, we only have data through April, but we've set records in January and April for each of those locations, and then for 2 of the 3 locations in February, and dropped down slightly in March, but then came back up in April. So that trend continues. One of the questions is, well, what's causing that? We're not quite sure at this point, but back in 2010, the causes of the abrupt change in sea level that resulted in a new record sea level that occurred in 2010 was due to 2 dominant factors. The first was a strongly negative phase of what's called the North Atlantic Oscillation. This is basically the way the pressure system set up over Greenland and the Azores, such that you have what's called a blocking pattern that sets up over the North Atlantic Ocean. And the jet stream dips to the south and steers storms up the coastline. This blocking pattern results in a weak onshore flow against the east coast of the United States, which raises sea levels. At the same time, it was found that what is called the Atlantic Meridional Overturning Circulation, or basically think of it as the lifeblood of the Atlantic Ocean, which moves warm water from the tropical areas of the Atlantic to the North Atlantic up near the British Isles. That water sinks and becomes denser and sinks and becomes cold and then returns over a long period of time. But when this system slows down, it can actually allow water to slosh against the east coast of the United States. And that's what happened along the entire East Coast in 2010, such that we had record sea levels in 2010. Is that what's happening in 2003 and 2024? We're not sure yet, but we have definitely seen an abrupt change. So in 2020, the Climate Council adopted a scenario of an intermediate sea level rise scenario for commit to manage, which was 1.5 feet by 2050 and 4 feet by the year 2100. So this graph is showing you the long-term tide gauge data from Portland, which again is our longest serving tide gauge in blue, and then the low, intermediate, and high sea level scenarios out to the year 2050 from work that we did in 2020. You can see there's quite a range between those. They spread out very, very quickly. But looking at the data, we're currently trending up near that intermediate line. In 2022, the Intergovernmental Task Force released a new report on sea level scenarios that are informing the U.S. National Climate Assessment. And those scenarios slightly changed from the 2017 report that we used in our preparation of the 2020 STS report. So the black line now is showing Portland data out through 2024 as it relates to the new intermediate scenario, which now goes out to the year 2050, you can see. Before, they used to just go out to 2100. You can see that there's a lot of constrained data out to about 2050, and then the bands of uncertainty get wider and wider as we go out to 2100 and beyond. So our adopted commit to manage scenario of 1.5 feet by 2050 is this blue dot here, and 4 feet by 2100. Well, these all fall within the likely range of the new intermediate scenario. So our finding is that Maine should continue to stick with our adoption of this 1.5 and 4 feet by the year 2050 as a good scenario to be working on for our commit to manage scenario. And note that 2023 and 2024 are actually above where this line is. For the prepare to manage scenario, which is 3 feet by the year 2050 and 4 feet by the year, or 8.8 feet by the year 2100, you can see we're now landing outside of the newly constrained bands of the likely range for the high scenario. However, what this simply does is it's shifting our data 2 decades back. So if we're talking about 3 feet, instead of having it occur in 2050, it'll be occurring in 2070, and 8.8 feet potentially could be occurring, somewhere around the year 2126 or so, instead of the year 2100. Nuisance flooding is also something that has increased along the Maine coastline, as many coastal property owners and municipalities have experienced, and it's especially increased over the last 20 years. This is long-term data, flood data, where the number of days where the flood threshold in Portland, Maine has been met or exceeded. And if we look at the data back to 1912, it's about 4 times per year, this black line. However, over the last 20 years, it's been about 10 times per year. So again, about 2.5 times what it was historically, which kind of matches what we've been seeing in terms of our rate of sea level rise. And you'll notice in 2024, we've already seen 18 events where that has been exceeded, the flood threshold. So nuisance flooding will continue to increase with sea level rise and a lunar nodal cycle, with a peak of the cycle in 2037. So the way the moon and the sun set up influence our tides. And the lunar nodal cycle is supposed to increase our tidal range as we go into the 2030s. So this is a graph showing how this might increase, and showing a 50th percentile or a central estimate, and then a likely range and a very likely range with some value. So in 2024, this is saying we should be seeing somewhere around 14 flood events per year. Notice we've already had 18 in just through April. But by 2037, at the peak of this, we could be seeing somewhere between 35 and 59 in the likely range of flood events per year. And sea level, of course, is also exacerbating coastal flood impacts from storms. This is a cartoon that kind of shows how this works. So minor coastal flooding starts in Portland at the king tide level, which is about 12 feet. There's only a 1 foot difference between our king tide and what we call our 10-year storm level. And then there's also only 1 additional foot difference between our 10-year storm and our 100-year storm. So as sea level rises, our baseline for flooding increases, so that these weaker events can have more of an impact on our coastline. What that looks like from the January 13th storm, 2024, is this. So the blue line in this is the simple tide predictions for the Portland tide gauge. Okay. The red line is the observed water level. So what we're seeing here is not only storm surge occurring from the storm, but it's being exacerbated a bit by sea level rise. And it just so happened that on the January 13th storm, the storm surge matched up right with the highest portion of the tide. So we set a new water level record here, okay? Now, it's not apparent how sea level is impacting this in this graph. So what I wanted to do is share with you very quickly how our the component of storm predicted tide in blue, storm surge in red, and then how sea level has changed that over time. So the farthest left graph over here, the plot on this graph, is our historic storm from 1978, which set a record water level of about 14.2 feet. You can see that was about 11.3 feet of tide, 2.9 feet of surge. However, this is the event from January 10th, so about 9.8 feet of tide, 3.3 feet of surge. But then there was that 0.6 feet of anomaly of sea level on top of that exacerbated that. And then it was this event, this 14.57 feet that we reached in January 13th, that had an 11.2 foot tide and a surge that was lower than what happened in January of 1978. But because of the sea level rise that has occurred, we've seen that event become much higher. And if you want to learn more about the sea level trends and how the ways we track water levels, we have a wonderful tool called our Sea Level Rise Dashboard at the MGS site. You can look at how that variability has been occurring over the months, our long-term changes, how we're trending in terms of our long-term and short-term changes as it relates to the sea level curves that we've adopted at the state, and then track kind of those nuisance flood events that have been occurring at different tide gauges. With that, I am done, and I would like to then pass it along to Nichole to speak with you about more of the marine system. Thank you.
Thanks, Peter. Let me get my screen up. There we go. All right. Hi, everybody. My name is Nichole Price. I'm a senior research scientist at the Bigelow Lab for Ocean Sciences in East Booth Bay. Come and visit us if you haven't seen us yet. I serve as a scientist, but also the director for our Center for Seafood Solutions. And my training, my background is as a marine ecologist. I'll sort of take off from where Peter left off, thinking about sea level rise. Let's think about what's been happening very recently with sea surface temperature change in the Gulf of Maine. So in the years 2021 and the years 2022, we had the highest average annual sea surface temperature records to date since the records began in 1982. And we all know that the Gulf of Maine is warming faster than almost everywhere else on the globe, but we are now aware also that the Gulf is warming 3 times faster than the global average for about a half a degree centigrade per decade. Since 2010, Maine has entered a new regime where our average temperatures are around 11.3 degrees Celsius. That's about 52 degrees Fahrenheit, if you're not familiar with Celsius. And this is certainly a new environment for all of our marine organisms to be living in. In 2022, Gulf of Maine also met the marine heat wave criteria, or a prolonged extreme periods of warmer conditions in the sea surface for 97% of the year. So these are very abnormal conditions for our organisms to be dealing with. That's what's been happening, well, in the past decade, and really since the first report that came out from the STS in 2020. But now let's look at what the projections are for warming and for the rate of change in ocean acidification in the Gulf of Maine from here on out. Our updated models are projecting sea floor warming of up to 2.75 degrees Celsius by 2050. So these are some new models that allow us not only to look at sea surface temperature, but at the sea floor, where a lot of our commercial fisheries species live. Some of these same new models also project that the aragonite saturation state, which may be an unfamiliar term to you, but it's a measurement of the calcification potential for different shellfish species. So for a saturation state of 1 or below, it will be pretty much impossible for organisms to build shells. And there's been a threshold discovered through scientific experimentation of 1.5 for aragonite saturation state. Below that, it's just very difficult for these organisms to make shells. And above that are the conditions that they favor. These new models project that the conditions in the Gulf of Maine will be below that 1.5 threshold for most of the year. And these projections for our report this year, released this year, 2024, are more extreme than have been reported previously, especially for ocean acidification. So conditions are looking challenging. We have, as a state, already been facing challenges affiliated with right whale populations that is strongly associated with climate change. So there are higher extinction risks associated with climate change-driven changes in foraging environment and habitat use for right whales. And some of the modeling efforts that have been done to figure out where right whales are becoming redistributed are using the likelihood to evaluate the likelihood of strikes and entanglement in particular regions. A lot of those models are driven by the redistribution of the prey, the Calanus phenmarchicus, which is a zooplankton species that these right whales are feeding upon. And the shifts in distributions of that prey, the Calanus phenmarchicus, is driving some of that change in distribution patterns of the right whales, which is leading to a higher likelihood of strikes and entanglement. The redistribution of those prey species are affecting not only the right whales, but other wild capture fisheries as well. So as we're aware, the lobster fisheries are continuing to report relatively slowed landings in addition to all the other challenges that they face. And these are consistent with climate change driven predictions. Part of this we're discovering is because the timing of the lobster egg hatch and zooplankton, or the calanus seasonality, has become mismatched. So the larval lobsters are hunting for the prey when it's not available. And that shift in phenology is contributing to other species losses as well. Some of our subpolar species are projected to continue to decline. Like our cod species, obviously we've lost, but other fish species as well. At the same time, we have other species that are rising in abundance, like squid, sea bass, and Jonah crabs. They're sort of following their preferred thermal habitat up the coastline from southern portions. And for fisheries in Maine, it will become important to make sure that we have policies in place to allow for capture of new wild fishery species as they appear. Aquaculture is likewise affected by climate change issues. So we've heard a couple of times about the storms that happened in January that caused significant flooding and surge along coastal Maine on top of sea level rise issues. This caused about $70 million in public infrastructure damage, largely along the working waterfront. While it might not have damaged the aquaculture farms, in many cases, it did destroy some wharves, docks, landing areas that makes it challenging then for the product to be brought to market and to be stored safely in refrigerated trucks, and for those refrigerated trucks to even access these places to pick up the landings. So the storm damage certainly will impact our aquaculture industries as well. Further, these heat waves or sustained exposures to high temperatures is impacting the brood stock of many species, including for seaweeds. And there's another scientist at Bigelow who has a paper coming out that has documented the loss of certain kelp species in the southern portions of Maine. And particularly during the summer months, and particularly during the times when brood stock needs to be collected for those hatcheries to get established. Finally, harmful algal blooms are becoming more frequent, lasting longer, and shifting in their seasonality. But all is not bad news here. We are discovering other ways to try to mitigate climate change using ocean-based strategies. There's two areas of interest in the Gulf of Maine in particular. The first is thinking about blue carbon and capitalizing not only on the salt marshes and seagrasses that we know are submerged aquatic vegetation that can capture carbon, but thinking also about sequestration potential from our wild kelp or from our farmed kelp. And there's several substantive research projects underway to establish the requisite baselines to understand how those species may contribute to carbon capture and storage along our coastlines. There are other projects underway to look at whether or not zooplankton may contribute to carbon storage as well. And then finally, we're looking at wind power off the coast of Maine. It's an ongoing exploration of potential ecosystem impacts for these alternative sources of energy. There's building evidence that the soundscapes created by wind platforms will not disrupt fisheries per se, but any impacts that these wind farms may have on the marine ecosystems in which they are immersed are likely to be very site-specific and need to be evaluated case by case. I think I will stop there. Thank you.
Great. Thank you so much, Nichole and Pete and Steve, for those excellent presentations. really informative, and we have lots of great questions coming in. So I would love to start fielding some of those questions. Just as a reminder to folks, these slides and the recording will be available on our website on the Maine Climate Council calendar webpage if you'd like to dive in to any of these topics again. And I did have a question for maybe for Steve, just to clarify, if folks are interested in learning more about, you know, if there's a figure in one of these slides or a source that they want to go and read more about, is that something that they can find in the upcoming scientific and technical subcommittee assessment when that comes out?
Well, certainly there is. We have lots of even hot links in the report, so that if you get the PDF version online, download it or work with it online even, you can go straight to some of the source information from those, read the original materials and trace it back. And so, yes, all that information is intended to be open and available to everybody for a reanalysis and discovery. So yeah, good question.
Great. And again, that report should be out very soon, within the next few weeks. So we're very excited for that to be available publicly. Okay, I'm going to start off with questions. So this first one I think is probably for Pete or Steve. So will the STS advise the Maine Climate Council this time around to add storm surge to its sea level rise projections for statewide planning purposes? And or how will how does storm surge factor into planning for communities that are interested in knowing more about that in addition to sea level rise?
I can start on that. Steve, please jump in if you'd like to. We are providing storm surge information along the coastline for the Climate Council in our report. We didn't make the specific recommendation that it should be included in planning for sea level rise, because sea level rise is kind of like the baseline. We provide statistics for storm surges that do occur based on the percent chance of that storm surge occurring in any given year. So think of it as the 1% storm surge is the 100-year storm surge. The 10% is that could occur in a 10-year. A 10% chance in a given year. So those kind of statistics are provided, but we haven't made a specific recommendation at this point about whether or not, you know, a certain storm surge, for instance, should be planned for on top of sea level rise.
And I'll just add to that, that the surge amount that somebody would consider for a particular location really depends on the risk that they want to plan for, whether it's a 10% event or a 100-year storm, that sort of thing. So the tables, as Pete said, are all there, so you can pick and choose what kind of a problem you want to try and address and over what timeline. So combination of sea level rise and storm surge is integral to doing the correct kind of resilience planning or adaptation. Yep.
The one thing I'll add to that, and then we can go on to the next question, is there is a newer model that is being developed, being led by Maine DOT, which is going to be a statewide dynamic inundation model. So what that means is it will not only account for sea level rise, but also storms, different recurrence interval storms. So in that will be storm surge data that will also include the impacts of waves, something we haven't really talked about in any of this. So that will be a much more dynamic model that is being developed and hopefully will be done within the next 2 years or so. And that data will be available to communities to help plan.
Great, thank you both. This next question is for Nichole. Does the average seafloor temp vary dramatically along our coast? Will we see shellfish be able to thrive in certain parts of the Gulf of Maine but suffer in others? Any evidence that the shellfish are evolving to tolerate higher marine temperatures?
That's a good question. We are not in the fortunate position of having an array of sensors across the floor in the Gulf of Maine to be able to answer directly how it varies here, there, and everywhere, but it would certainly vary from location to location. Are there places that will be more suitable for shellfish growth than other places? I imagine there would be, but it's a really interesting question as to whether any are evolving to be more resistant or resilient to climate change, warming, and or acidification. I know a handful of reports that have found pockets of corals or other shellfish species that have been subjected to warmer conditions and acclimatized to those conditions over time. Whether or not they pass those traits to their offspring is certainly an active area of research and a matter of interest. And whether or not we can selectively breed, not genetic modification, that's not what I'm talking about. I mean, selectively breed, picking a mom and picking a dad that have both exhibited that resistance to warming, and choose their offspring as what we use for aquaculture conditions. That's another area of research, but having the policy framework in place to allow for selective breeding of those species and outplanting them at different sites is something that's still in development, I would say.
Another question for you, Nichole. Did climate change in warming seas play a role in last summer's large brown algae bloom event in the Gulf of Maine?
That's another good question, and I have to be frank, I don't know. And I don't know if anyone knows the answer to that question yet. Apologies if someone does, but I think that we are seeing new microalgal blooms and new macroalgal blooms that are unexpected. And it would be a parsimonious explanation that it was related to some of these heat wave conditions that are unprecedented. But I wouldn't say that we have causal and effect evidence in hand as of yet.
All right, this next question could be partly for Pete and partly for Nichole. Why is the Gulf of Maine so different from the rest of the ocean as to both temperature and height?
Nichole, do you want to start with that one, or do you want me to start?
Why don't you start, and I'll see where we go.
Well, I'll just talk about it from the standpoint of sea level. So there are a variety of different currents that influence the Gulf of Maine. One is the Labrador current, which actually brings cold water down from the northeast Atlantic down along the coastline. We also have, of course, the Gulf Stream, which is offshore, which is moving up and to the northeast, I guess you could say. The Gulf Stream plays an interesting role because sometimes there are actually gyres that break off of the Gulf Stream and move through the Northeast Channel and into the Gulf of Maine that can influence water temperatures. The main factors that are influencing sea level, though, on a global scale and also a local scale, is thermal expansion. That's accounting for about 50%. So that's literally the heat that's being trapped in the water column. And that's gone up significantly since the 1950s, not only in the Gulf of Maine, but also for the global oceans. So from a sea level rise standpoint, as you warm the water column, it has a chance to expand. And as it's expanding, sea levels will go up. So, but maybe you can address the other temperature aspect, Nichole.
Why it's warming faster in the Gulf of Maine? I guess the easiest explanation is the combination of the circulation patterns that Peter described with the fact that the bathymetry in the Gulf of Maine relative to elsewhere is fairly shallow, and so the pools of water that come in here get to sit around for a while and warm up more easily than elsewhere in the globe. So just think of your kiddie pool in the backyard getting nice and hot. That's the best analogy I have for it.
And I might just step in and say too, that the way I think of it is the Labrador current is in an old-fashioned sink. It's like the cold faucet, and the Gulf Stream is the hot faucet. And lately, the hot faucet has been on and overwhelming the cold faucet. So the water just outside of George's Bank is coming in mostly from the hot tap, and therefore its circulating has been in there. So that's been since about 2008, 2010. And we've asked other scientists too, when's the cold faucet going to get turned back on, or is it? And it's hard to predict that, but it's really the dynamics just outside the Gulf of Maine that are influencing the water temperature regime in the Gulf. And to go to the other part of the question about sea level rise too, the trends we've seen in sea level rise overall inside the Gulf of Maine are similar to the world ocean. But there's also been this spike in the last couple of years, since about June a year ago, in the Gulf of Maine tide gauges going up. And that is also quite similar to what's happened along the eastern seaboard of the United States, all the way down through the Cape Hatteras and to the Key West area. So we are not alone in that extra elevation of water that we are experiencing here in the Gulf. Thanks.
Thank you all. Super interesting. I love hearing those different explanations. Question for Pete, perhaps. Could you describe the tools used to measure sea level rise or sea level in Maine? And if you, I know from recently reading the STS report that there are definitely some need for additional measurement and information in this area. So if you want to riff on some of the priority information needs in this area, but yeah, I would love to hear more about the tools
Sure.
that we are currently using to measure sea level.
Sure, and it's actually, you have to go back a little bit, I guess, in the answer. If we went back 100 years, what was being used then to monitor sea levels is very different than what's being used nowadays. I mean, there used to be monitoring stations that were set up that basically had kind of floats inside of a tube, and also like a tide staff, or literally a staff with marks on it next to it. And that has graduated over time to basically pressure sensors that sense how water moves inside of a tube, that then telemeters data directly to a computer and saves it on a hard drive, but also telemeters it somewhere. So the whole concept is still the same. You have a sensor that is out over the water, or actually in the water. And as that water goes up and down inside of a tube, that's being recorded. So that whole concept is still the same. It used to just be a float versus a pressure sensor. And on a global scale, sea levels are also being monitored by satellites. There have been a number of satellites that have been deployed, and you can actually find this if you look up the University of Colorado's sea level rise research program. They do a great job of compiling the satellite altimetry data that's been compiled from, I think, 4 or 5 satellite deployments now, going back to 1993. So satellites orbiting the Earth are able to take pictures, and from those pictures, and you can do altimetry measurements to measure the surface of water. Water's not equal everywhere. It's kind of like a bathtub all the time. If you slosh one end, the other end gets higher. It's not just a static surface everywhere. So our global oceans are always varying. But getting to what Molly brought up, Maine only has a few long-term tide gauges in place. Portland, Bar Harbor, and Eastport are the longest serving ones. We also have shorter serving ones in Cutler, and also at Seavey Island down near Portsmouth. A couple of those were offline for a couple of years. One of them moved for a couple of years, but the network of keeping track of water levels is really, really, really important, not just from a long-term sea level monitoring standpoint, but understanding how there's spatial variability in the way that water levels interact with our coastline. So if we have a southeaster coming up along the coastline, one section of the coast that sticks out and faces southeast is going to be hit very, very much differently in terms of the water levels, as opposed to something that is, say, on the northeast side or the northwest side of an island, where you're kind of in the lee of the oncoming storm. So having localized water data is very, very important for localized planning, because a storm is going to impact a section of the Maine coastline very differently just a couple miles away, based on the way the geology and the shape and geomorphology of our coastline.
Great, thanks, Pete. This next question I think is for Nichole. What is the feasibility and status of ocean alkalinity enhancement as a way to use the ocean for carbon capture?
Thanks. It's a tricky question. So maybe to summarize briefly for others who aren't familiar, there are a couple of proposed marine carbon dioxide removal strategies circulating out there. One I discussed, which is the blue carbon approach, or carbon capture by things that do photosynthesis. Another is ocean iron fertilization, which is adding more iron to the open ocean to spur algal bloom of sorts, where a lot of carbon is captured and then theoretically sunk to the ocean floor. And another is this alkalinity enhancement, which to think of it very simplistically is giving the ocean a big dose of Tums to reduce ocean acidification. The feasibility and the relative efficacy and the cost of any one of those marine carbon dioxide removal strategies is a very active area of research. And there are groups at Bigelow who are pursuing questions about each of those, for instance, but also all over the globe. It depends who you ask, their opinion, which one is the better approach to go. The approaches of iron fertilization or alkalinity enhancement may be able to cover a bigger area, but they're going to have an expense affiliated with conducting them and unknown ecosystem consequences for those approaches. There will be unknown ecosystem consequences for considering seaweed farming at massive scales to reduce carbon dioxide as well. There'll be some expense affiliated with that, but also potential revenue. So there's pros and cons to each of the approaches. And really what the scientific community is trying to gather itself to do right now is to figure out how to conduct research experiments for any one of those approaches in a ethically and ecologically responsible manner. So we don't have the answers as to which one of those is the best yet, or if we should try all of them or none of them until we kind of set those boundaries and guidelines about how to do the research in a responsible way.
Great, thanks, Nichole. This next one is, I think, for Pete, sort of a clarifying question on the sea level rise projections. And feel free if you want to throw your slides back up to illustrate this. If the Gulf of Maine is rising twice as fast as expected, how can the commit to manage and prepare to manage projections remain the same? Could you explain that one more time? And again, feel free to show your slides if that would help.
Sure. Was it twice as fast? Somebody?
The person asking the question asked if the Gulf of Maine is rising twice as fast as expected. So that might be the clarification.
Yeah. Okay. Yeah. It's not necessarily twice as fast as expected. It's roughly 2.5 times the long-term trend, which is going back to 1912. I think that's an important distinction. But going back to the overall question, the whole idea of the science behind what is influencing sea level rise has become more focused in terms of the scenarios. So, and I'll just kind of, without bringing up my slides. So in the 2017 scenarios that we used to kind of inform the 2020 assessment, we were looking at scenarios that by 2050 were like this already. So there was like a low, a low intermediate, an intermediate high, a high, and what we call extreme. Okay, so the band, even out to 2050, was like this. The understanding of ice sheet science, thermal expansion, the storage of groundwater, localized crustal adjustments, and all that has gotten much better, even just over the last 4 years. So the scenarios now, and especially the science relating to the roles that ice sheets are playing in this, in their instability, is telling us that instead of having scenarios that go like this out to 2050, now we have scenarios that are like this out to 2050. So we have a much better idea on how these scenarios, they're much better constrained in terms of the uncertainty. And they're all relatively close now out to about 2050. Once we get out, beyond 2050, this is where the scenarios start to go like this and get a little bit more and more uncertain. And that has a lot to do with Antarctica and Greenland, what's going to be happening with they're going to become the major contributors to sea level rise as we go on into the future. Right now, it's about 50% thermal expansion and the ice sheets. So the science that constrains those is getting better as it relates to the shorter term, but we're still unsure as we go out to the long term in terms of ice cliff instability and things that can dramatically raise sea level over a shorter term. The other thing I wanted to throw in there is the scenarios now go out to 2150, which I think is a really, really important step, because our assessment in 2020 only went out to 2100, and all of the science is pointing that beyond 2100 sea level will continue to rise. It's not going to suddenly reach a plateau, and then suddenly stop. What is going to be impacting that is the greenhouse gas emissions. Are very, very important because that impacts how much heat is being trapped in the upper ocean and therefore warming it and expanding it. And therefore also the greenhouse gas emissions influence what's happening with Antarctica, Greenland, and also other land-based glaciers that over time contribute to sea level rise because they result in water that runs into the oceans. So moving that, I think that's a very important step showing that, you know, we need to be thinking about this issue beyond the year 2100. I think the last part of the question was the prepare to manage scenario also. So what was interesting with that was we were using the high scenario from the 2017 assessment, which again had a much higher band of uncertainty in terms of what that scenario looked like. That scenario is more constrained now. So our scenario lands above the likely band now of that for the prepare to manage, but we highly recommend leaving that in there because it just pushes the numbers back about 2 decades. So it's important when we're thinking about critical infrastructure, when we're thinking about infrastructures that's going to be in place for the next 100 to 150 years, that we consider a higher scenario than what has been adopted as the commit to manage scenario. We still think the commit to manage scenario is very, very valid given what we're seeing in terms of the rates of sea level change. I showed you how it's relating to those different curves. And the nice thing is that when the Climate Council was set up, we decided every 4 years we're going to be revisiting the science. So we can then take a look. And if something dramatically changes in terms of what the science is telling us, there can be revisions made. So I think that's a very good, smart thing to do.
Great, thank you, Pete. All right, there were, you did touch on this a little bit. There's a couple of folks asking about increased ice cap melting. So the first question is just recognizing that some recent glacier studies are indicating that melting rates have been seriously underestimated in the past. Can you just clarify whether that new information that's coming in is accounted for in the current projections?
Yeah, we definitely considered them. All the data and papers up through, I guess, March were kind of included in this effort. So it's not new to us seeing some of those papers, and they're included in our chapter. We still think it's, again, valid to consider that high scenario. But at this point, the commit to manage scenario is the one that we felt was the one that Maine kind of needs to stay the course on in terms of our planning. So yes, the answer is yes, that information was reviewed. It is included in our paper. There's a lot of uncertainty still as we get beyond the years 2050, especially even out to 2100. There's a lot of uncertainty as to what's going to happen with the major contributors, which are those land-based ice sheets. But yes, they were taken into account.
Great, thanks, Pete. And then just can you clarify, is there any evidence that the increased ice cap melting in Greenland is affecting the Labrador Current?
Yes, there was a paper that came out that looked at that specifically. And what's happening is it has to do with the salinity of the water and the freshwater input that's occurring from the melting of the land-based ice sheet of Greenland that is influencing the Labrador Current. It's still something that is, relatively new in terms of what's being looked at and how the science is evolving in terms of that. But the Labrador Current is most likely being influenced by melting of the Greenland ice sheet, and that has to do with the freshwater pulses that are coming out and the salinity gradient between the current and the freshwater pulses that are coming out of Greenland that are influencing the Labrador Current. So yes, that is something that is something we need to keep our eyes on for sure.
And I'll just quickly add that there's the Atlantic meridional overturning circulation that Pete mentioned in his slideshow, which is the larger convection and conveyor belt system in the North Atlantic. And the freshwater melting there also influences that deeper circulation and the speed of water movement in the North Atlantic, which in turn affects the Gulf Stream speed and can affect the sea level along the coast. So the melting in the Greenland area is important in those two different ways, perhaps as much so in the Gulf of Maine from the ocean circulation side as opposed to the Labrador Current.
Great, thank you both. I think we
Awesome.
have about time for one more question. This last one is for Nichole. Thinking about the future and what will become the new normal in the Gulf of Maine, are there policies being considered to support the fishing industry if they need to transition to harvesting new species?
It's a good question. It's a complicated one because depending on the fishery, it can be managed differently. It can be managed at the state level or at the federal level. And basically what needs to happen is that for our region or across the state boundary, there needs to be development and recognition of new quotas for new fisheries that we might not have any for yet in the state of Maine. And that I'm not a policy person, but as far as I know, that needs to be either advocated for at the state level or at the federal level by our state representatives, to just make sure that we're watching the change in biology and then being prepared to capitalize on it if we can safely do so. But it's those quotas and getting those quotas set for each different fishery type that will take some doing and careful consideration.
Thanks, Nichole. And I just wanted to chime in that I know that the Coastal and Marine Working Group of the Maine Climate Council has been developing some policy recommendations to help Maine's fisheries become more adaptive and help our policies support any transitions that will need to happen. So those conversations are happening right now and should be reflected in the next climate action plan, which is of course what we want to see out of all of this new science, is to have it be reflected in the policies that come out of the climate action plan. All right, well, I want to give a huge thanks to our presenters today and to all of you for asking the wonderful questions. We got more questions than we could answer, but I hope that you will all be able to take a chance and look at the scientific assessment when it comes out. I personally am looking forward to it. There's an executive summary in there that can help folks who maybe are non-scientists but are still interested in diving into these topics to see what some of the top highlights are, and then maybe dig deeper into a topic. So that's something that you can look out for. If you're on our newsletter, please stay subscribed so that you can be notified when the report is released. And again, these slides and recording will be available on our website after the presentation. And you can always contact the Maine Climate Council, reach out to us if you have questions or additional information that would be helpful for you. So we look forward to hearing from you, and thank you again so much to our experts for joining this presentation today.
Thank you, Molly.
Thanks, Molly. Thanks, everyone.
All right, take care, everybody. Have a great afternoon.
See ya.
Thank you.